Guys, so today we're going to learn about how to transform different functions. So you may see something like this where you have a graph or a function known as f of x, and then you have various transformations that happens. So what happens in these scenarios? Well, the best way to go about this is if we draw a graph, and we can use the help of GeoGebra to do this. So if we have a look at the graph of y is equal to x squared, or the function um, f of x is equal to x squared over here. So this is what our graph will look like. Now, what if we were to have the function y is equal to x squared plus 2? Now, intuitively, all we're doing is adding 2. So our y value should increase by 2. And if we have a look here, when x is 0, y is also 0. However, here, when x is 0, y is now 2. So our y coordinate has increased by 2. Likewise, over here, when x is 1, if we have a look at this coordinate over here, when x is 1, y is 1. However, on this graph, when x is 1, y is now 3. So again, our y coordinate has increased by 2. And that's going to happen all across this blue graph. Our y coordinates are increasing by 2 each time. Now, what about then? What about, so as we said, this is quite intuitive. If we add 2, our y coordinates are going to increase by 2. Now, what about over here then, when we have x plus 2 all squared? Now, as we can see, our graph is shifted to the left by 2 units, which is kind of counterintuitive because if we're adding 2, surely our graph should move to the right. But that doesn't quite happen. And a way of thinking about this is that we're arriving at each coordinates 2 units earlier, hence why our graph has moved to the left. So here we had 0, 0, but now our x coordinate is minus 2. So we have subtracted 2 from our x coordinate. And that happens all along the graph. So for example, over here, our x coordinate was 1, but now our x coordinate is minus 1. So we've subtracted 2. And likewise, on the green graph, or the graph of y is equal to x squared, this coordinate is minus 1, but the new coordinate is now minus 3. So we've essentially done the opposite. And instead of adding 2, we have subtracted 2 to all the x coordinates, or subtracted all the x coordinates by 2. So if we go back to this here, in effect, we can kind of understand this as a rule. And you can explore this in more detail if you wanted to using GeoGebra or Desmos. But as a general rule here, if the transformation is inside the bracket, then it affects the x coordinates and we do the opposite. So here, instead of adding 2, we minus 2 from all of our x coordinates, whereas over here, the transformation is outside of the bracket. So it's going to affect the y coordinates, and we do as it says. So we're going to add 4 to all of our y coordinates. So if we go back over here, if this is the function f of x, and now we have f of x plus a, we are going to add a unit to all of our y coordinates. Likewise, over here, we are going to minus a units from our y coordinates. Here, we are inside the bracket, so we're saying f bracket x plus a. So we are going to subtract a units from all of the x coordinates. And likewise here, we are going to add a units to all of our x coordinates. So we'll see this in more detail in a moment. So this is a classic exam question. So we've got the function y is equal to f of x. It doesn't really matter what this function looks like. However, we are told that the coordinates of the turning point is 6, 5. Write down the coordinates of the turning point on the curve with the equation y is equal to f bracket x minus 4. So over here now, it's inside the bracket. So the transformation is inside. If it's inside, it's going to affect the x coordinates, and we do the opposite. So in essence, we are going to add 4 to all x coordinates. So the new turning point is going to be 10, 5. We need to add 4 to 6. So the new turning point is going to be 10, and the y coordinate is not affected. And for the meantime, we can skip this part over here, and we can come back to that later. So, excuse me, let's have a look at this question. So we've got y is equal to f of x. Now, it says draw the graph of y is equal to f of x minus 4. Now, this time the transformation is on the outside. So outside, it's going to affect the y coordinates. And we do as it says. So we subtract 4 from y. So we can pick this point over here. Our y coordinate is currently 0. So if we subtract 4, our new y coordinate is going to be at minus 4. Likewise over here, this is currently at 0. If we subtract 4, our new y coordinate is going to be minus 4. And remember, the x coordinates are not affected, so we only need to worry about the y coordinates. The x coordinates stay as they are. And then we can pick this point over here. So currently the y coordinate is 1. So the new y coordinate is going to be minus 3. So we're going down 1, 2, 3, 4. And this is going to be at minus 3. And likewise, this is going to be over here. And then with a ruler, we can join our points up. This is the transformation completed, which we can say is actually a translation. And if you wanted to think about transforming shapes in terms of translations, rotations, reflections, and enlargements, essentially what's happening here, we have a translation. Okay, let's move on to this question over here. So now this time, the transformation is on the inside, so we are going to subtract 2 from all of our x coordinates. So minus 2 from x coordinates. Excuse me. So now we can start from this point over here. This is nice and easy. And if I minus 2, I'm going to go back 1, 2. So that's this point over here. Then I can pick this point over here. So currently our x coordinate is at 0. So now it's going to be at minus 2. So going back 1, 2. Likewise over here, this is almost at 1. So we are going to go back 1, 2, and it's going to end up over here. And this one is going to end up at 0. So 1, 2. And then you could make a rough sketch of these points as well. So we're going back 1, 2. So that's roughly going to be around here. And then this one, we are going back by 2. So we're going 1, 2. So that's going to be roughly around there. And then we are going to sketch this. Can be a little bit difficult at times. And that is going to be, and let's not forget our turning point for that matter. So 1, 2. So that's going to be somewhere around there. And in effect, that's what our new sketch is going to look like. So we've gone back 1, 2 here, we've gone back 1, 2 there, we've gone back 1, 2 there, and 1, 2 over here as well. And likewise, 1, 2 over here, and 1, 2 over there as well. And from here, we've gone back 1, 2 over here as well. So it doesn't have to be perfect, but as long as we've shown a shift of 2 units along the x-axis, you should get the marks. And remember, don't use a ruler to join the points up. It has to be a nice curve. Okay, so let's have a go at the next one. Now, this one here, again, the transformation is on the outside. So this is going to affect our y coordinates. But what we're saying is 2 times f of x, essentially. So what that means is we are multiplying all of our y coordinates by 2. So now, if we have a look at our y coordinates here, so initially our y coordinate here is 0. But over here, our coordinate is at 91. 1. Over here, we've got 180, 0. Over here, we've got 270 minus 1. And over here, we've got 360, 0. So if we multiply all of our y coordinates by 2, that's going to lead to a stretch in our graph. Now, over here, 0 times 2 is going to be 0. So there is no effect on the y coordinate over there. However, here, 1 times 2 is 2. The x coordinate is not going to move, so our graph or our new point is going to be over here at 92. Likewise, over here, we've got 180, 0. So 0 times 2 is still 0. So there is no change there. However, over here, we're at minus 1. So minus 1 times 2, that's going to take us to minus 2. And likewise over here, 360, 0. 0 times 2 is still 0. So we stay at 360, 0. So we can see we've got a stretch in our graph over here. And that's the effect that it will have if we had 2 on the outside. So we're saying 2 lots of f of x, so all our y coordinates are being multiplied by 2. Remember, if it's outside, it affects the y coordinates. Now here, it's inside, so it has to affect the x coordinates. But remember, we said if it's on the inside, you do the opposite to the x coordinates. So rather than multiplying our x coordinates by 2, we are going to divide the x coordinates by 2. So this is really important to understand. Rather than multiplying by 2, we're doing the opposite, the inverse. So we are going to divide all the x coordinates by 2. So let's see what happens here. Well, again, currently we're at 0, 0. So 0 divided by 2 is still 0, so that stays as it is. However, over here, we're at 91. The y coordinate is not going to change. However, the x coordinate is now going to become 45. So this is our new coordinate over here. Likewise, if we ever think about this point here, 180 divided by 2 is now going to become 90. So this is the coordinate 180, 0. So 180 becomes 90. So this coordinate is going to shift over here. And then this coordinate, so 270 is going to become 135 because 270 minus 1 is the original coordinate, but if we half 270, that's going to give us 135, so that's going to end up over here. And hopefully you can kind of see what is going to happen. We are now going to get 2 cycles within a 360 interval. So this is our first cycle, and then we are going to get another cycle within that 360 interval. So if we again think about 360, well, 360 is going to become 180. So that's going to end up over here. And then in effect, we are going to get 2 cycles. And that's really it. So if it's inside, we do the opposite to the x coordinate. So in other words, we are dividing our x coordinates by 2. And it kind of makes sense because we are now getting 2 cycles in the same time frame, if we think about it like that. So let's have a look at some more questions like these. So now we can do part B. So here, the transformation is on the inside. So the effect is going to be on the x coordinate, and we are going to do the opposite. So rather than multiplying by 3, because this is 3x, we are now going to divide our x coordinate by 3. So 6, 5, well, if I divide the 6 by 3, my new coordinate is going to become 2, and the y coordinate is going to stay the same. So 2, 5 is our answer. So write down the coordinates of the turning point. This is the coordinate of the new turning point. Okay, let's have a look at these ones over here. So it says the coordinates of the maximum point on the graph is 1, 3. So this is the maximum point. This is going to be 1, 3. Write down the coordinates of the turning point of the curves with the equation y is equal to f of x plus 2. So it's inside. We're going to do the opposite. So we are going to subtract 2 from our x coordinate. So this is now going to become minus 1, 3. And that is our answer. Over here, now we've got a minus on the outside. Now you can treat that as a minus 1. So you could think of this as y is minus 1 f of x. So in other words, we're saying minus 1 times f of x, and the minus 1 is on the outside. So that's going to affect our y coordinate. So the x coordinate will stay as it is. So we are going to multiply the y coordinate by minus 1. So we are going to end up with 1. 3 times minus 1, that is going to be minus 3. Excuse me. And now we have y is equal to f of x minus 4. So again, the minus 4 is on the outside. So we are now going to subtract 4 from our y coordinate. So that is going to leave us with 1 minus 1. And lastly here, the minus is on the inside, so that's going to affect our x coordinate. And again, you could think of this as y is equal to f minus 1x. So in other words, we are multiplying x by minus 1, so we need to do the inverse and divide x by minus 1. So 1 divided by minus 1 is still minus 1. So that is going to give us minus 1, 3 over here. All right. Okay, so let's move on. Let's have a look at this question here. So now we've got two transformations happening. So we've got the minus on the inside. So we are going to divide x by minus 1 because we need to do the opposite. The opposite of times n by minus 1 is to divide by minus 1. And then we've got the minus 3 on the outside. So we do as it says. We are going to subtract 3 to y coordinates. So in effect, we are going to divide this by minus 1, and we are going to subtract 3 over here. So our new coordinate for Q is going to be minus 7 and minus 1. And really, the question looks a little bit complicated, but if we follow the rule, we shouldn't have any problems answering the question. Okay, let's try some more. Now, here is an example of a difficult question. You wouldn't get something like this on GCSE papers. However, you could get something like this on an IGCSE paper. So if you are doing IGCSEs, please stay tuned in. Or if you want to challenge yourself, you can go ahead and do that if you are doing other exam boards. Now, what we need to do is first draw our sine graph over here. So you should be familiar with your sine graph. So with our sine graph, we are starting over here at 0, then at 90, so 30, 60, 90, we reach 1, and then at 180, we go back down to 0, and then at 270, we go to minus 1. And then at 360, we go back to 0. Now, another thing we want to do with a question like this is to draw a x-axis so that this graph here is symmetrical. Now, if you think about our original sine graph, there is symmetry here. So this line creates symmetry. There is a gap of 2 there, and there is a gap of 2 there. So if we have a look at the overall distance here, we are at minus 2.5 and we are finishing at 3.5. So that's going to be 2.5 plus 3.5. That gives us 6. So the halfway point is going to be 3. So we need to draw a line over here. So if we have a look, we are going 2.5 plus another 0.5. That gives us 3. So this is where I'm going to draw a line with a different color. Here we go. So hopefully you can see the symmetry here now. And we've got 1, 2, 3, 4, 5, 6 squares from the maximum point to the red line. And likewise from the minimum point, 1, 2, 3, 4, 5, 6. Now, as we can see here, there is no movement along our x coordinates. So the transformation will only affect our y coordinates in this one. So what we need to see is, well, what is happening here? Now, if you think about it, then we can pick this coordinate and this coordinate over here. Because remember, these two coordinates would have been affected. So this coordinate here, 360, 0, has now shifted over here. And this was 360, 0. Now, we are multiplying the y coordinate by a amount. However, 0 times a is still 0. And then we are saying plus b to get to a coordinate of 360, 0.5. So we can say is equal to 0.5. So this coordinate is currently 0. So the y coordinate is currently 0. 0 times a is going to give us still 0 plus b amount to give us 0.5. So that means b must be 0.5. So find the value of a and b. So b must be 0.5. And then in that case, we can now compare this coordinate and this coordinate over here. So here our y coordinate is going to be, so we've got our x coordinate of 90, we've got a y coordinate of 1, and likewise over here we've got our x coordinate of 90 and our y coordinate of 3.5. So in effect, if I just rub this out, we said b is 0.5. So what we're saying is 1 times an amount, so 1 times a plus 0.5 will give us 3.5. Now we can just solve this using algebra. So 1 times a is a, so a plus 0.5 is equal to 3.5, so a must be 3. And that is our answer. So we've got the graph of 3 sine x plus 0.5. And does that make sense? So let's just quickly test it out. So 1 times 3 is 3, plus 0.5 is going to be 3.5. So this is our answer over here. It really helps if you draw this line to ensure you can see the symmetry for the new graph that has been transformed. Right, guys, I hope this has helped. And we can, again, put our answers over here in the answer section. So A is 3 and B is 0.5.